Hello, today we're going to be talking about proportional relationships. So our goal today is determine if ordered pairs form a proportional relationship in tables and graphs. We're going to do a little bit of background information to remind you about what ordered pairs are. Ordered pairs you're going to be finding in parentheses, a comma in between. The first number is going to tell you the x-coordinate, and the second will tell you the y-coordinate. So for example, down below here, we have an ordered pair, 6, 42. Remember that the first number represents our x-coordinate, the second number represents the y-coordinate. If we are going to be comparing these as a rate, we're going to be writing our y-coordinate and comparing it to our x-coordinate. So Mrs. Armentrout, we're going to fill in our y-coordinate of 42 and our x of 6. Now, if we want to be writing this as a unit rate, remember we will be dividing by the denominator, so dividing both numbers by 6. So we have 7 to 1. In our second example, we have an ordered pair 2 and 4/10 and 12. So not always will they be whole numbers, sometimes we'll have rational numbers. Again, we're going to be comparing our y-coordinate to our x-coordinate, so that would be 12 compared to 2 and 4/10. If we want to find our unit rate, we are going to be dividing. Remember that if there are numbers that you would like to use a calculator for when you're finding the unit rates, you may do so. Now that we have a reminder about what ordered pairs are with our x and y coordinates, we'll move on to a table.
All right, so we are going to show you a multitude of ways to determine proportional relationships. And the first way is using a table.
As a reminder, before you listen, pause the tape and make sure you write down this table first, and then you can continue.
The first thing that we want to remind you is that when we are writing these, we want to, these rates, these ratios, we want to write them with the y going first and the x going second.
Now notice we have 1, 2, 3, 4 sets in our table. All of these have to be the same rate if they are going to be proportional. The way the tables are set up, you're going to have your x first and your y second. So you can think in your head, oh, this is just like I saw. It really is an ordered pair if I would put in the parentheses and the comma. So we need to take each of these and simplify and see if they are the same. So Mrs. Armentrout's going to write the first one, 3/1/2. Remember, if we have a complex fraction and we're simplifying, we're going to be multiplying by the reciprocal. So 2/1.
By now you should be getting pretty good at these. So this would work out to 6. And remember when we were multiplying by the reciprocal, 1 times 2 is 2, 2 times 1 is 2, 2/2 is 1. So that brings us to the unit rate.
In our next, remember again, you can imagine the parentheses with the comma in between. And that one
is already in a unit rate because the second number, the denominator, is 1. So we'll just line this up right here.
In our third set, we have 9 and then 3/2. So we have another complex fraction.
Remember that we're going to find the unit rate. We are going to multiply by the reciprocal. And that is going to give us, of course, the 1 in the denominator. But over here, when we multiply this out, 9 times 2 is 18. And 1 times 3 is 3. 18 divided by 3 is going to give us that 6. So far you can see
that they are proportional because all three are the same. We have one last set to check.
If I were a betting girl. All right, and if we do the same thing, dividing both of these by 2, you will see that we indeed have a proportional relationship. Another method that we're going to show you is using graphs to determine proportionality, to determine if we have that proportionate relationship. We're going to show you two examples here. Let's start with this table.
Now take a moment and in your notes, pause the tape and copy down table, draw the graph and the table, and when you're ready, then you can start the tape.
All right, so if we take a look at our first table, as Mrs. DeGrant said, Mrs. Lush, oh my goodness! You just remind me of her so much, maybe with your bubbly personality. All right, so we're going to put our parentheses around there, indicating our ordered pair. So X, remember, we always place the X first and the Y second. And so we're going to start at 0, which is another name for the origin. Origin is our starting point always, and it stands for 0, 0. So we start here and we go to the right 2 because we have a positive 2, 1, 2, and then Y is on 6, so we go up 6, and we put our little dot right around there.
I notice that in my next set, I have 4 and 8, so I'm going to start at my origin, count over 4, and then I'm going to count up 8.
And last we have 6 to 10, and so we're going to go over 6 and up 10. We're going to do the best we can here. Or that a little bit. It's not. Just going to do the best you can with those.
All right, next you're going to take your ruler and you are going to connect the dots. So I'm going to line them up. And draw my line going through. Now I'm going to be looking at this line, and by looking at the picture I can determine if it has a proportional relationship. So looking at that picture, there's two things I'm noticing. Number one, I'm noticing that it is a straight line. I don't have any curves or bends in it. So down below I'm going to write that down. I notice that straight line.
The second thing that we're going to take a look at is if this line would keep going and extend, it is not going to pass through the origin. It will not pass through the origin. So we're going to note that. Now, one thing that you need to make sure you have written in your notes is that to have a proportionate relationship demonstrated, there are two requirements. One is you need a straight line. And the second is that it must pass through the origin. So your line must.
This one does not. So this is not going to be a proportional relationship.
All right, and when we're explaining and showing our proof, here it is. We have one of the requirements, but you need both. Let's check with our second table to see if we are going to have a proportionate relationship. So we're going to use a different color, and we're going to plot our points for 1, 2, and 2, 4, and 3, 6.
Use my ruler, line them up.
All right, so when we take a look at that and do a little analysis, we are noticing first that again we have a straight line. Okay, cool beans. We've got one of the requirements. Second, we're noticing that indeed this goes through the point of origin. So it goes through the origin. Because both requirements are filled, we would say yes to this table. In our last notes here, we are going to interpret proportional relationships in a graph.
Okay, looking at our table, I notice that the first is in time, measured in seconds, and the second is distance measured in inches. Over in my graph, I have my X on the bottom, which is time in seconds, and my Y on the side, distance in inches. I'm going to have you pause the video and record the table and the graph before we begin.
Make sure you have your labels.
Okay, now that you've had a chance to put this in your notes, we are going to take this information and put it on our graph. So our first set that we have is 0, 0. Remember, one of our requirements for being proportional is it passes through the origin, so we have one requirement met. Now our next one is 1, 1 1/2, but we don't have 1 1/2 on our graph, Mrs. Armentrout. So how will we do that?
So I know that 1 1/2 is going to be exactly in between 1 and 2 for the y-axis. So I am going to plot my point right there.
And our last ordered pair is 3, 4 1/2.
And I'm going to do the same thing, making sure that I have my right. Okay.
And when I put down a ruler, it goes through all of them, so that means that we also have our second requirement, which is a straight line. So we have a proportional relationship because it goes through the origin, and we have a straight line. Now, what do all of these points on here mean? So if I take a point on here and I say, well, what does that mean, 0, 0? On the top, the graph is labeled beetle speed. So it's telling us how fast this beetle is traveling. So if I look at 0, 0, what does that mean? It means that the beetle travels 0 inches in, well, that's not good with the in 0 seconds. Well, I wonder what this next point means. That would mean that the beetle travels 1 1/2 here, 1 1/2 inches in 1 second. Now, if you are given the distance in 1, remember that's our unit rate, so that's going to be how far that beetle is traveling.